Thank you. Well, thank you, first of all, to the UK Digital Twin for inviting me to present today. I'm Moises Sanchez. I'm a lead research data scientist at the Consumer Data Research Center, which is funded by the UK Economic and Social Research Council, CDRC. And I'm going to be talking about what is the Consumer Research Center in terms of data resources and data products that are available within the center. And I'm just going to do that briefly in terms of have time afterwards in order to go more in depth in terms of the digital twin topics. So the CDRC contains different data sets that are provided to researchers. These data sets contain different type of information across different domains: population, mobility, finance, economic, and it has 3 tiers of security: open, safeguarded, and secure. And they have different providers within this data providers in collaboration with us in the center, from Wemfresh, Airbnb, Compass, Mastercard, among others. And these data sets can be accessed by researchers from abroad, from the UK, filling a form and following the procedure accordingly. In terms of use cases that are enabled by these data sets, range from COVID-19 vaccine accessibility, resilience of British High Street within the COVID framework, how wind farms can power by 2023 the households, how the consumer insights about consumer data and housing policy, and among others. There are many use cases that can be accessed, and if you are more interested within the CDRC website, they are aiming to ask and answer questions about the different socioeconomic domains, like for instance, why some retail centers outperform others, predicting the ethnicity in the future of the UK. So all these topics are within the interest of researchers, the domain public domain, and also businesses. From these use cases, there are different data products that are available within the CDRC, available for the public, available and across different websites, and available in the CDRC website. So I'm going to be talking a little bit about some of these data products in the form of services. So the first one is the Priority of Places of Food Index. This particular service aims to quantify the risk of accessibility of food across the different places within the UK. This quantification is done within different criteria domains on type of supermarkets, locations, etc. It is a completely interactive dashboard, has awarded the different prizes, and if you are more interested in figuring out what are the processes and techniques in order to enable this type of services, so you can visit the website of this service. Another one is the carbon footprint calculator. This particular service enables the consumer to input a recipe and quantify the carbon footprint of this recipe product by product within the recipe of food. So this enables the users to make informed decisions about what will be the best option in terms of consumption, in terms of being in a restaurant or in a cafeteria, etc. We have the nutrient profile model calculator, again within the domain of food systems. This inputs a different set of products and quantifies the product nutrition components. Transport, speed, and behavioral patterns. This service potentially be enabled in the future. It enables a finite analysis which helps the transport planning, road safety, urban reliability, and helps with excessive carbon emissions. So this set of services and products here within the center, we're aiming to gather them together in order to enable potential digital twins within the socioeconomic domain. But the complexity of this particular domain is quite large, as you might know. Here in this slide, I'm depicting the different levels of complexity of digital twins, starting from the left-hand side with the traditional operations, getting more complex in terms of enabling data operations, connected operations, digital enhanced operations, and the most complex one will be connected ecosystems in which the socioeconomic digital twins will fall. So this is the digital twin framework that will architecture, general architecture for like not the most complex digital twin, but next to the most complex one that we saw in the previous slide, which comprises techniques, cutting-edge techniques like cloud, modeling, using elements, contains of information architecture that will enable this modeling accordingly. Key techniques you can see in the lower part of the slide will be semantic models, knowledge graphs, ontologies, AI, in order to be able to enable the flow of information that is required within these complex systems and higher interconnectivity that these systems will require. So we need to start moving away from this previous architecture in terms of even if it will enable near to complex systems or complex enough systems, these socioeconomic digital twins have higher complexity. So we need to start moving away from a technology-centric digital twinning towards a more technology in society model approach. This will comprise to enable three main components: the data interaction within the environment, which is the standard digital twin that monitors a real process. Also, we have to enable the data interactions with other digital twins with other digital twins. So we are able to build digital twin networks. So these semantic models, the modeling will have to be a miniaturization in order to enable these larger networks of digital twins. So they will have three main aspects, characteristics. We'll have a synchronized interconnectivity. We'll have a very dense interconnectivity itself in order to enable higher value services. And the key features that we want to enable with these digital twins is scalability, interoperability, intelligibility, and primarily that is useful. So this is the overall architecture that we are proposing, of course, based on literature, state of the art, in which we have here at the lower part of the presentation the real-world processes that will enable or enable a digital twin, one process per digital twin. But here is when the connectivity among the digital twins starts, in which they start the flow of information start happening. Then we have in the next layer of the architecture federated digital twin, in which they are gathering digital twins information. It's gathering digital twins information from various digital twins. And then within these federated digital twins, that will enable services that will be able to be interconnected in order to maximize the information that a user of the digital twin within these complex systems will be able to do. So just to finalize here briefly, the architecture of the digital twin to some extent is available within the state of the art to the point in which you are able to enable services. But in order to enable a digital twin able to deploy and operate within the socioeconomic systems, you have to be able to connect those services in order to maximize that value of information that is required within these complex environments. So here I'm just showing some references. If you are interested, this set of references will summarize this perspective of the architectures described above. So if you're interested, so happy to have answer any questions if you might have one later. Thank you very much.
So Moises, how much do you think semantic models and knowledge graphs could contribute to the challenge of interoperable data between organizations and sector?
Yes, I think these two technologies or approaches are key for being able to handle this high interconnectivity. On one hand, you have the knowledge graphs that can be updated, can be queried, can be built even automatically these days by large language models. And having these knowledge graphs updated and available to provide information across from different domains and towards different domains in terms of digital twin components is key. Also, this knowledge graph needs to be backed up by ontologies in which we have a consensus or a standardization and agreement across stakeholders on how the different domains information will be labeled, the concepts, in order to have this consistency in information and smoothness flow towards the upper level of the architecture in which the higher value of information is generated.
Moises, how important will standards be in your framework for connected digital twins? Which domains would you draw these standards from?
Yes, standards are key, as I mentioned, also for the knowledge graphs in terms of having ontologies agreed and built across stakeholders. There are other frameworks that will enable these standards, like there are so many of them, like the resource description frameworks, it's called RDF, to describe the exchange of data graphs. There are other very used frameworks in terms of the industry foundation classes for the description of data for architectural building construction industry. There are other frameworks for the key technologies that will enable this standardization for technologies that could be useful, such as agents, microservices, architectures, containerizations, Docker, IoT technologies, fog computing, Kafka frameworks for knowledge graphs, again, GraphDB, GraphQL, for the ontologies, the web ontology language, OWL, Protege software, etc.